Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to discuss about channel handshaking in AXI. So all the 5 signals use the same valid and ready handshake to transfer the data and control information. So we have already seen, let's say suppose if in our write address channel we were using this handshaking signals like AW valid and AW ready. This was the handshake signal we were using, and let's say suppose in our read address channel we were using the handshake signal like ARW valid and AR ready signal, and in our data channel also we were using the valid and ready but with different notations. So whatever the 5 channels which we were having in our AXI, so these 2 signals we were using, valid and ready handshake signals, we were using for transferring the data and control information. So with that only we are going to come to know that okay, our data has been successfully transferred or not. Okay, so basically this two-way flow control mechanism enables both the master and slave to control the data rate at which the data and the control information moves. Okay, now the source is going to generate the valid signal. So whatever the channel it may be used, the source is going to use a valid signal, and it is going to indicate whether the data or the control information which is available is a valid or not. Okay, so using the valid signal we are going to indicate that we have already seen in our previous sessions also, like for example your write address channel was using AW valid to indicate the validness of your, or whether the data is available is a valid data or not. Okay, so the master was using AW valid and it was using W valid. Okay, in the write data channel it was using W valid. So here the source is going to use the valid signal and the destination is going to generate the ready signal. This also we have seen in our previous sessions. So the destination is going to use a ready signal and the source is going to use a valid signal, and the destination is going to generate the ready signal for indicating that it accepts the data or the control information. So for the control information we have a valid signal, and for data also we have a set of valid signals. For example, the control information like our AW, for example if we have a address channel, then for by the slave we are going to use a signal which is known as AR ready signal, so that your slave is ready to accept the data or not. Okay, so here the major important point to be noted is the transfer is going to occur only when both the valid and ready signals are high at a time. So if your valid and ready signals are high, then you can say your transfer has been completed, or else you cannot acknowledge that your transfer has been completed or not. This is a very important mechanism using which your master and slave, or the source and the destination, are going to communicate with each other, and they are going to end the transaction or complete the transaction. Okay, now in that so this is what we are going to discuss in our today's session, the handshaking mechanism between the master and the slave. So before going to start this particular discussion, I want you all to once please take your time, subscribe to my YouTube channel. We are very close to 10,000 subscribers, and if you like this video, at the end you can like this video and you can share it with your other VLSI aspirants, and you can also provide your feedback in the comment section so that we can come to know whether to improve ourselves or what type of content you are expecting and what type of changes you are expecting. Yes, so we will start our session. Now, let's say the data or control information from the source remains stable until the destination drives the ready signal high. So here the important rule to be noted here is whatever the information, this information may be a data information, or it may be a control information like address, burst, anything. Okay, this particular information should be constant. Until and unless the destination is going to drive a ready signal. So here you can see, until and unless your destination is going to drive a ready signal, your data and control information is constant, that is, it is stable. Okay, and if you got this particular ready signal as high, by your receiver or the destination, then you can see at this particular point both valid is equal to 1 and ready is equal to 1. Okay, so at this particular instance of time, your ready is equal to 1 and this signal will be sampled by your source at this particular edge of clock. Okay, so at this particular instance, your source is basically sampling the ready signal, and here you can mark that the transaction has successfully completed and the source can successfully change the information. It may be a data or control information, it can change it. Okay, so using this valid signal, so this is a point at where the source can change the information which is present here. Okay, so the main point to be noted here is the data or control information from the source that should be stable until the destination drives the ready signal. Okay, so it indicates that it accepts the data or control information, and you can see the arrow shows when the transfer is going to complete. So here the transfer is going to occur. Okay, now next important point here to be noted is the destination drives ready signal high before the data or control information is valid. So your destination is allowed to drive the ready signal even before the data is allowed and even before the valid signal is given. Okay, so even before the valid signal and the data information or control information given by your source or your master, your slave can drive the ready signal high before this particular point. Okay, so basically this indicates that the destination can accept the data or control information in a single cycle as soon as it becomes valid. So you can see here, whenever your valid became 1 in this cycle, immediately in the next cycle, since your ready is equal to 1 and your valid is equal to 1, here the transfer will be occurring and this will be completing. Okay, so this arrow shows where the transfer is going to occur. So at this particular point, the transfer is going to occur. Okay, so this is one point. What is this point? Basically, your ready signal can be made to 1 even before the data information or control information and your valid information is present. Your slave can assert your ready signal and it can be ready for sampling your data. Okay, next is both the source and destination happen to indicate the same cycle, that they can transfer the data or the control information. So what we can perform here is, your master or your source can make your valid signal to high whenever your information is available. At the same time, your ready signal can also become 1, indicating that it is ready to accept the data. But if it is made to 1 at this particular cycle, then in the next cycle, this ready signal will be sampled by your master, and this point indicates that your transfer has occurred and it has completed successfully. So the third point is your valid and ready signal become high at the same time. And previously what we have seen is your valid and ready signal, your ready signal can be made to 1 before the information and the valid signal was become to 1, and at the third point we have seen that your valid signal and ready signal can become 1 at the same point, and the next cycle, in the same cycle your data has been completed, your transfer has been occurred. Yes, so let us try to understand some points where we need to where the protocol is saying or recommending you some particular points. Let us try to understand it. Now, coming to a write address channel, we will move one by one channel. So the very first channel which we are going to discuss, handshaking mechanism in our write address channel. Now, in the case of our write address channel, the master can assert AW valid signal only when it drives valid address and valid control information. For example, let us take a scenario and a slave like this. Okay. Now, let's say if our master wants to start a transfer. Now what it is going to do, it should first of all provide a address information, whether it can be a write transfer or whether it may be a read transfer. First of all, the master needs to need to provide the address. So using this, if it is a write transfer, the master is going to provide the AW address using the write address channel. Okay. Now after that, it is going to assert a signal which is known as AW valid, indicating the control information which is present is a valid information. Okay. Now, so the master is going to assert this AW valid signal only when it drives the valid address and control information. Okay. And this must remain asserted until the slave accepts the address and control information. So this AW address and AW valid signals should be stable until and unless your slave is going to provide the handshaking signal, that is our AW ready signal. AW ready signal. So until and unless your AW ready signal is equal to 1, that is asserted by your slave to be 1. So until and unless this signal is made to 1, your master should maintain this AW address signal and AW valid signal stable, so that your slave can sample this control signal and whatever the signals which you have sent, whatever the address and control information you have sent. So after sampling those signals, your slave is going to assert this AW ready signal, indicating that it has successfully sampled those particular signals. Until and unless this particular signal is made to 1, your master is not allowed to change this AW address and AW valid signal. The same thing which we have learned in AHB and APB protocol also. Now, coming to the default value of this AW ready signal. So what should be the default value of this AW ready signal? This is indicated by your AXI protocol. So the protocol basically suggesting us to make this AW ready signal can be either high or low. But the recommendation given by our protocol is keep this AW ready signal to high. If our AW ready signal is high, then the slave must be able to accept any valid address that is presented to it. Okay. So we need to make sure that our slave is ready for accepting the valid control and data information. But if you think your slave is slow, and let's say if it needs time to process some data, then this value is not recommended. AW ready signal to high, the default value is not recommended, because if your AW ready signal is equal to high, then that means your transfer has been completed and the master is allowed to change the valid and the master is allowed to change the address and control information. You need to make sure that your master is ready for that. Okay, so in those particular cases, according to your requirement, you should make sure that what should be the default value of your AW ready signal. Okay, yes, so this was about your write address channel. Now let's say if our default AW ready value of AW ready value of low is also possible, but it is not recommended. Why it is not recommended? Because it implies that the transfer take at least 2 cycles, one to assert our AW valid and another to assert AW ready signal. So what does this means is, our AW valid signal is made to 1 in this cycle. We took at least 1 cycle for this, and whenever your slave sees this valid signal was asserted to 1, then in this cycle it is going to assert this ready signal to 1. So the transfer to complete, it is going to take 1 and 2 cycles. Basically it is going to complete. So the transfer it is going to complete. So the transfer to complete, it is going to take 2 cycles. Whenever your ready signal, the default value of your AW ready signal is equal to 0, for the transfer to complete, we need at least 2 cycles. But if your default value of your AW ready is equal to 1, then what is going to happen? For asserting your valid signal, we need only 1 cycle. So in this particular same cycle, in this edge, but here we can see the transfer is completing in only 1 cycle. You can see here in this particular cycle, our transfer has been completed. So this is the difference. What happens if you keep your ready signal by default to 0 and by default to 1. Okay, so that is the difference. You can watch it out. So a default value of your AW ready signal values of low is possible but not recommended, because it implies that transfer takes at least 2 cycles, one to assert your AW valid and another to assert your AW ready signal. So this is your case of your handshaking in your write address channel. Now coming to next channel, that is our write data channel. Now during a write burst, the master can assert the W valid signal only when it drives the valid data signal. This we already know. After providing the valid address and the control information, then if our master wants to perform a write operation, then it is going to use a write data channel and it is going to provide the burst of data items to our slave. Now whenever it is going to provide this data items, it is going to use a signal which is known as W valid signal that indicates that whatever the master is sending, that is a valid data information. Now this W valid must remain asserted until and unless the slave accepts the right data and asserts the W ready signal. So this data whichever the master is providing to the slave, that must be stable until and unless we get a response or a handshaking signal or a response signal from our slave that it is ready to accept the data. Okay, that it has successfully sampled the data. So until and unless this W ready signal was made to 1, our master should maintain this data stable. Okay, so the default value of our W ready can be high, but only if the slave can always accept the right data in a single cycle. The same scenario which we have seen in our address, that same thing we are also going to follow in the write data channel. So if we think the slave can accept the data within a single cycle, our default value of our W ready, which is going to be asserted by the slave, can be high. But if we think our slave cannot accept the data within a single cycle, then our slave should not keep this default value to high. Okay, it should keep the default value to low. Whenever it feels like it can sample the data and it can complete the transaction, it is going to make that particular W ready to high. Okay, and the master must assert the W last signal when it drives the final write transfer in the burst. So we have already seen this, the W last signal is going to be asserted at the end of your burst. And next comes the write response channel. So the slave can assert the B valid signal only when it is going to drive a valid response. So if the slave is going to provide a response to our slave, then using our response channel, then it is also recommended, but then it is also should provide your B valid signal. Our slave should also provide our B valid signal so that the master will come to know that whatever the response it has received is a valid response. And B valid must remain asserted until and unless the master accepts the right response and asserts B ready. So until and unless your master gives you your B ready signal, your slave should provide your slave should maintain this B valid to be stable. Okay, and whatever the response it is providing, it should be stable. Okay, and whatever we have discussed in our previous points, those are all applicable here also. Okay, and coming to read address, the same thing which we have discussed previously, and coming to read data also the same thing. Now let us see one particular diagram and let us try to understand what is this handshaking mechanisms and what is the handshaking mechanism that should be followed between different channels. Okay, now let us see this. We have a AR valid signal which basically belongs to read address channel, and we have the signal which is known as AR ready signal. This also belongs to read address channel, and R valid signal which belongs to read data channel, and we have R ready signal which also belongs to read data channel. Now what is the relation that we should follow here is your AR valid signal. The AR valid signal is given by our master. Now this AR valid signal is given by our master. Now what is the relation here is, let's say if we have our master and a slave like this. Okay, now basically what is the condition which was given by the protocol is we have our AR valid signal which was given by our master, and we have AR ready signal which is given by our slave, right? Now here our AR ready signal can be asserted to 1. This condition we have seen already in our previous slides. Okay, this AR ready signal can be made to 1 before our AR valid becomes 1. Before our AR valid becomes 1, our AR ready signal can become 1. Okay, our AR ready signal can be asserted to 1 before our AR valid becomes 1. So this is what the diagram is basically saying you. Our AR ready signal can be asserted before your AR valid becomes 1. So here also the same thing which we have written. So the slave can wait for AR valid signal to be asserted before it asserts AR ready signal. So basically the slave can wait for this AR valid signal before asserting AR ready, and this or else it can also make this AR ready to 1. Okay, it can wait, or it can also make the AR ready to 1. Okay, this thing we have discussed previously also. But you can see there is a double arrow. That means this should be followed compulsorily. This should be followed compulsory. Now what is this requirement which we are going to have is our R valid signal should wait for the assertion of AR valid signal and AR ready signal. Now let's say, let me erase this diagram. This is our master and this is my slave. So I have two channels. One is read address channel and another is read data channel. So basically I have two channels, read address channel and read data channel. Okay, now I want to perform a read operation, so I can clearly get to know that I am going to perform a read operation. Now if my master wants to perform a read operation, then what it is going to do, it is going to give a read address information using the read address channel, that is nothing but AR address. Okay, now we have something known as AR valid signal, AR ready signal by the slave, and AR valid signal, AR valid. So here your AR ready signal can be made to 1 before your AR valid was made to 1 by the master. Okay, so your AR ready signal can be asserted to 1 before the master asserts this AR valid. But the condition here is, next channel which we are going to have, this is our read address channel. Let me mark it down. So this is my read address channel. Now next set of channels for reading the data which we are going to have is our read data channel. So next set of signals which we are going to have is R valid signal. This belongs to your read data channel. Now this R valid signal must wait for your assertion of AR valid signal and AR ready signal. Until and unless your AR valid becomes 1 and AR ready becomes 1, your R valid is not allowed to become 1. So this is what the diagram is going to tell you. So your R valid signal is not allowed to asserted until and unless your AR valid and AR ready becomes 1. This is the major condition which we need to follow. Now before your R valid, so this is the condition which we need to follow here. So that is what it is written here. So the slave can wait for AR valid to be asserted before it is going to assert AR ready. It can wait or it cannot wait also. Okay, but the slave must wait for both AR valid and AR ready signals to be asserted before it is going to return the data by asserting R valid. So this is the condition which we are going to follow. Okay, now and there is one more condition, is your R ready signal, it can wait for the assertion of R valid signal, or it can make this signal high before R valid becomes 1. Okay, so there is a single arrow. That means you can wait or you can skip that. Okay, it means there is no compulsion. So your R ready signal can wait for the assertion of your R valid signal, or it cannot wait, or it may not wait for your assertion of R valid signal. So before your R valid signal becomes 1, your R ready signal can be 1. Okay, now so concluding this particular point, your AR ready signal can be made to 1 before your AR valid becomes 1, or else your AR ready signal can be 1 or can be asserted to high after your AR valid signal become 1. Now coming to this R valid signal, this should be asserted to 1 if and only if your AR valid signal is equal to 1 and AR ready signal is equal to 1. And coming to this R ready signal, it can be high before your R valid signal is equal to 1, or it can be high after your R valid signal becomes 1. This is the condition which we need to follow in the case of your read transaction handshake. Now coming to write transaction handshake, let's say if we have our master and a slave and we need to perform a write operation. Okay, now if we want to perform a write operation, what the master is going to do, it is going to provide the address information using the AW address, and it is also going to provide the AW valid information and we are also going to get the AW ready information, AW ready. Now here the condition is your AW ready signal can wait for the assertion of your AW valid signal. That is, after your AW valid becomes 1, then your AW ready can be 1, or else this AW ready signal may not wait. There is no compulsion that your AW ready signal should wait for your AW valid signal. That means even if your AW valid is equal to 0, your AW ready can be 1. Okay, this is one condition. Now we have, after completing this transfer, that is AW valid and AW ready, both are equal to 1, then only the master is allowed to assert another signal which is known as W valid. This comes under write data channel. Only if your AW valid and AW ready signal becomes 1, then only the master is allowed to make this W valid to 1. Until and unless these two signals become 1, that is the transfer, before completing this transfer, your master is not allowed to make this W valid to 1. This is the thing which we need to follow. Now we have one more signal which is known as W ready. Now this W ready can wait for the W valid signal to be asserted. That means even if your W valid is equal to 0, your W ready can be 1, or else after your W valid becomes 1, your W ready can become 1. These are the two conditions which we need to follow. Okay, next we are going to have the response. Okay, only after your W valid and W ready becomes 1, only after your W valid and W ready becomes 1, then only master is allowed, then only the slave is allowed to make this B valid to 1. Only then your slave is allowed to make this B valid to 1. Until and unless your W valid and W ready are equal to 1, your slave is not allowed to make this B valid to 1. After W valid and W ready becomes 1, your slave can assert your B valid to 1. And we have one more signal which is nothing but B ready. Now this can be asserted to 1 even before your B valid becomes 1, or your B ready can wait for the assertion of your B valid signal. That is, after your B valid becomes 1, your B ready can become 1, or else even if your B valid is equal to 0, your B ready can be equal to 1. So this is the handshaking mechanism which we are going to follow in the case of your write transaction. So these are the handshaking mechanisms which we are going to follow in read transaction, and the handshaking mechanisms which we are going to follow in the write transactions. Yes. So that's about this particular session. So if you like this video, please like, share and subscribe to my YouTube channel all about VLSI. Thank you for watching this video.